Hi everyone, myself N. Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about parity generators and checkers. So these are all the slides we are going to see in this video: introduction, sources, even parity and odd parity generators, parity checkers, applications, and followed by assessment. So in this, we are going to check the even parity and odd parity numbers. So even parity means the number of one generation is even number. So odd parity means number of one generation is odd number. So in even parity generation, the bit 1011 means it is a number, three numbers has been generated. If you are adding 1 and 0, what is going to become? So if you are adding 1 means then it is going to become an even number. If you are adding 0 for this, then it is going to become a odd number. So we need to check the parity of the concern generation. So like this, all parity also we need to check 1011. So the number of generation is 3, 1 is generated. So if you are adding 0 means automatically it is a even odd number, so no need to add 1. So the data becomes a parity, odd parity. So like this, if you are adding 1 means then it is going to become a even number, so we need to check the parity. Sources. The common sources of errors are noise and interference, hardware malfunctions, software bugs and glitches. So these are all the common factor while creating an errors while forwarding the data from source to destination. Why data integrity matters? Because we need to check the data consistency as well as the accuracy and reliable data communication. So these are all things we need to check while forwarding the informations. Even parity generators. So the even parity generator means even numbers has been created while adding the binary bits. For example, if ABC is a 3-bit, if you are adding 1C1 means then the parity will be added as 1. So along with the binary numbers, it must be a even numbers. For example, C and P is the even number, so even parity has been generated. Like this, we need to check all the 8 bits. So for example, 101 means it is also a even number, so we no need to add 1 in the parity, so it is going to become a 0. 111 means triple one, so it is a odd number, so then we are going to add 1 for parity, so that it is going to become an even number. After getting the numbers, we need to follow the boolean expressions. For example, if parity 1, so 0 1, so the corresponding terms has to be added here. For example, 0 means A bar and 1 means C. So 0 is A bar and B bar, so B equal to 0, so B bar, C equal to 1, so C. So like this, wherever the 1 is generated in the parity, we need to we need to add the Boolean expressions. A bar BC plus AB bar C bar plus ABC. After that, we need to conclude the answers as a Boolean reduction formula. So the common term has been reduced by using this method. A bar is a common, so I'm just taking A bar as a common term. The remaining term will be considered B bar C plus BC bar. So like this, B bar C bar plus BC. So it is going to become a XOR gate, and it is nothing but XNOR gate. So XOR gate and XNOR gate. After that, A bar X plus X A X bar. So it is also become a XOR gate. So I'm going to write my expression as A XOR B XOR C. So A XOR B is a XOR gate, and followed by A XOR B XOR C. So A XOR B and C is going to become another input, so that the parity will be generated A XOR B XOR C. Odd parity generator, so it is also same. If you are adding 1 for parity, then excluding all the bits as to be a odd numbers. For example, if you are consider this 0 1 0, then it is also a odd number, so no need to put parity as a 1 here. For example, 1 1 1, it is also an odd number, so no need to put 1 in parity. 1 1 is a even number, so if you are adding 1 means it is going to become odd parity. So after getting all those Boolean expression, we can have this A XOR B XOR C whole bar XNOR gate. So A XOR B XOR C, so it is a NOT gate, so I am just adding this NOT gate for this A XOR B XOR C for parity, odd parity generators. Parity checkers. So in parity checkers, we need to check the parity of the concerned bit. For example, 1010 means we need to have it is an even number. So if you are having any one Odd generation means then we need to check the corresponding all the bits of the concern checkers. And odd parity means the total number of one is odd, so you don't have any problem. If you are having even means we need to check the corresponding bit and then we have to generate it. Applications. So there are a lot of applications are using a data communication system, Ethernet, UART, RS-232 we are using regularly for real time, and digital storage device like hard disk, SSD, RAID storage systems. For example, the process or having any errors mean we need to check this data hard drives. Industrial applications, PLC programmable logic controllers, we are using this application as parity checkers and generators. And embedded system and IoT devices, it is commonly used for microcontrollers like ARM process and PIC microcontrollers. Assessment. A bank ATM transmits customer PIN data to central server. Explain how parity circuits can prevent the errors during the data transfers. So before sending the PIN data, a parity generator adds a parity bit to detect the transmission errors. The central servers uses a parity checker to validate the data. If the parity checks fail, the system requests the retransmission instead of processing the incorrect financial data, ensuring the secure and error-free transmission. Suppose if you are putting any wrong numbers in the PIN number, then automatically it recognizes that it is a wrong number, so we need to change or check your data. Like this, it will be generated based on the priority encoders. Thank you.